Hello everyone, welcome back to the Kafka Fundamental Tutorials. This is part 2. Uh, there was part 1. If you haven't watched it, please go ahead and watch that video. There is a lot of fundamentals about Kafka. It's important to know the fundamentals before we start coding. Helps write the code better. Okay? All right, just a brief recap of what we had. What is Kafka? This is how the architecture looks like. Basically, the producer produces messages, and Kafka has infrastructure which delivers the message to the consumers. This is subscriber publisher pattern. Okay. Each message or each topic can be divided into one or more partitions. Each partition has a broker. Consumers, they form a group. Multiple consumers can be assigned to one partition, okay, or a single partition, however the need be, okay. I'm going to skip these things. What is Kafka? Because these were all covered in the previous lecture. What is partitioning? What are Kafka brokers? What is replication? What are producers, consumers? These are the concepts. Okay, so here we go for today. Now, whenever an application is there running, errors are bound to happen. How you handle is called failure strategies. Like a producer may send a message, but for some reason, maybe the network has issues, the machine is down, or any XYZ issues, the message did not get delivered. So every application should have some failure handling strategies defined. Kafka has 3 strategies: fail fast, ignore, and dead letter queue. Let's see what is fail fast. This is the default strategy. Basically, fail fast in application context means as soon as the error occurs, any sort of error, you handle the error. Okay, the application, you stop everything, handle the error first. That is fail fast. Okay, like say network issues or any issues is there. So that is the fail fast, which is the default. So it stops the application immediately and marks it as unhealthy. So like when you have the health check URLs, it will return that the application is down. You know, every application has a health check URLs. Now some of the URLs are provided by default when you're using Quarkus. So like an application, something went down in between, the message could not be delivered. The connector will mark the application as unhealthy. So this is fail fast. Ignore, this is like while you're testing or doing some initial development work, as the name suggests, that the message comes, did not get delivered, their application doesn't care. Okay. It's hard to implement. I mean, not hard to implement, but it's difficult to imagine this kind of strategy being set up in production environment because the messages should be delivered. Or something like you don't care, you just as a publisher just distribute the message, you don't care who receives it or not. In that case, you could have problem. So maybe let's say you are a news publisher who just publishes the news, and you let the consumers who are not within your application try to handle the failures. Like you don't care if the if the news didn't get delivered or not. Some that kind of scenario. Okay, you would use the ignore. How will you set this up? In your application.properties or application.yaml, you will have this property set. Okay, this value set. The failure strategy, ignore. Okay. The next one, which is more widely used, is the dead letter queue or DLQ. What does this mean is when an application or when the producer sends the message, and for some reason the connector could not deliver the message, it stores it in a separate topic, which is called as a dead letter queue. So the message, it just simply saves it in another queue. Instead of passing it on to the subscribers, which it was unable to do it, it'll store it here. And then somebody who is any application or software which is monitoring the dead letter queue topic will decide what to do with this letter, like whether to redeliver, retry, all the strategies could be applied there. Okay. So again, 3 failure strategies: fail fast. Even if one message cannot be delivered, the connector marks your application as unhealthy, which is default. Then you had ignore, which is just in the initial phases of development, or if your use case is such that you don't care if the message can get delivered. In that case, you would use ignore strategy. The last one is dead letter queue, which means the messages that could not be delivered are stored in separate topic, which is known as a dead letter queue. Now, some other application or human being, somebody can monitor this and decide based on your use case what strategy to apply. How do you set the dead letter queue failure strategies? Again, in your application properties file, application YAML file, any configuration file that you're using for Kafka, this is what you're going to set. Okay, so this is failure. Then now, how to handle success, right? So the messages did get delivered. So if everything is running fine also, you need to know, okay? So we should inform Kafka that the processing succeeded. In this is the terminology which we call it as the offset commit. Basically what it means is that for every partition will have its own offset, okay? So let's say that all the messages before this message got delivered. All the message before this got delivered. So this is the offset commit, okay? Like it will mark the position of the record, okay? That this one got delivered. So now the next one is coming ahead, okay? The next batch of processes are not processed. So Kafka organizes records around topics, okay? Each topic has a name. Application can send records to topics and pull records, right? Pull means pull to the consumer. Topics are divided into partitions. Each partition is an ordered and immutable sequence of records. Sending messages to partition appends it to the end, okay? So this is the first, second, third, and the next message comes, it will be here. It appends to the end of the queue, okay? And again, how does it decide which partition it goes? Based on the message queue. Computes hash, computes which partition it will go to, and it will go there. Each message from the partition gets a sequential ID, which is called as offset. It uniquely identifies the message within the partition, okay? Like sequence, like 0, 1, 2, 3, 4. So in Kafka, you can identify one record based on the topic, partition, and the offset. So if we have to identify, say, let's say this record belongs to movies, partition 1, offset. This one belongs to movies, partition 2, offset 3. Because this is offset 0. So this is how you can uniquely identify. So these are what you call it as a coordinate or the tuple to uniquely identify any message. Okay. Again, committing strategies is letting Kafka know that all these messages were processed, successfully processed. So when an application consumes messages from Kafka, it uses Kafka consumer, of course. With this consumer, it pulls batches of records from a specific topic. Retrieve messages belong to partitions, right? Messages belong to partitions assigned to this consumer. Excuse me. Consumers belong to a consumer group. So see, this is group A, Too good. Sorry. Application A1 and A2 belong to A. Consumer group B, application B belongs here. Okay. Sorry, having a little cough and cold. So in general, when you scale up your application, it creates a group or new consumers join existing groups. Okay. And each group is assigned to a partition. So this group is only assigned partition 2. These two, A2 is assigned partition 2. And this one is assigned partition 0 and 1. Okay. And each consumer belongs to a consumer group. Now, to orchestrate each consumer's group progress, each consumer periodically informs broker of its current position. Like, I have picked up the record till here. I've picked the record till here. So that is what is called as offset. It commits this offset. Committing the offset means storing this information somewhere, okay, indicating that the previous records from that partition have been processed. Now, the frequency of this commit has to be kept in mind. It cannot be too soon, like very often, because that will hamper the performance. Because every time you consume a message, you have to commit. Every time you consume a message, you have to commit. Okay. And this is how the Kafka differs from other messaging services such as JMS, which acknowledges every single message. Now, what are the commit strategies? Earlier, we saw the failure strategies. Now, what are the commit strategies? Throttled, latest, and ignore. Okay, let's see what each means. What is throttled? Can be seen as asynchronous variants of the default auto commit. When enabled, connector tracks each received message and monitors their acknowledgement. When the connector finds out that all messages before a position are processed successfully, it commits that position. So it's like in a batch. It happens periodically to avoid committing too often so that we have improved performance. How do you set the property? Here, incoming channel, coming strategy, throttled. Okay. Again, this is defined in your configuration file or application properties or application your YAML or wherever you're configuring Kafka. Next one, ignore. The connector uses this strategy by default if you explicitly enabled Kafka's auto commit. Okay. So now in this case, the connector ignores the acknowledgement and won't commit offsets. The consumer commits the offset periodically when polling in batches. Okay. How do you enable auto commit? Here it is. Auto commit true. Okay. And commit strategy, ignore. If you don't enable auto commit, using this strategy is still possible, but it will never commit the offsets. Okay. In other words, you would restart from the oldest records every time you restart. Okay. So be careful with this strategy because Kafka doesn't know to which records you have processed. So it has to go to the oldest record, which is there. Latest strategy commits the offset every time a message is acknowledged. Now this tends to commit often. So therefore hinders on the performance. Okay. But the advantage is it reduces the risk of processing the same message more than once. Because every time the message is processed, it commits the offset. Every time a message is processed, it commits the offset. Okay. So pros and cons of each strategy. How do you enable it? You have the commit strategy property. Set it to latest. All right. Now, let's do some action. Let's see how actually some code of running Kafka. Okay. Now, before you actually run Kafka, you'll have to download Kafka, of course, right? Once you download it, I have Kafka 3. Which one is? Yeah. No, I have Kafka 2.13. That's what I have downloaded. You untar it in your home directory. There are 2 services that you need to start. One is the Zookeeper, and you pass the properties where you configure which port it should be listening to and all. And then you start the broker service. Here it is. So this is the second process. So before you run your application, you need to start. So this is your Kafka broker service, which uses the server.properties, and you will tell where the Zookeeper is running, all the ports and everything. And this is the Zookeeper service. So 2 services should be running before you can run Kafka. All right. Here's your application. Very, very simple. You have producer and you have the consumer. Okay. Simple. It generates a random number, double. That's all. See here. This is my topic, prices out. Here, consumer, incoming, my topic, prices, and it just prints out. You could do whatever you want, right? Basically, it's just simple. The packages you need to know is org Eclipse, microprofile, reactive messaging acknowledgement. You're using it here. In producer, also you're using outgoing reactive messaging, outgoing. Okay. So this is the producer and this is the consumer. So it will just generate some random number which could be equal to price and push it to this topic, prices out. Let me show you my application properties. So here it is. Prices out. The topic is prices. The topic name. Okay. There's some properties that were needed. The connector, small right Kafka. Okay. So basically the topic, the deserializer, serializer, deserializer, you need to specify here. Again, the topic is prices for incoming, and this was for outgoing. Okay. So prices out. So here you see prices out. Give the topic, all right? So this is a Quarkus application. So the command that you will give it is -w Quarkus staff. So when it starts, this you will see it once, printed it once, and then you will keep on seeing the consumer message that it got the price. Starting Quarkus, da 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 da. We are generating prices. This is from the producer. And now see, every second it generates a new price and the consumer keeps getting the price. See here, the consumer got price. So every time it generates some random number and publishes it. And the consumer, which is continuously listening to the incoming messages, just now here your entire application logic would go, what to do with the incoming messages, how do you process it, okay? And then what you're returning, see, you're acknowledging the message, every message, okay, that the message is received. And in case if it doesn't receive, it's NACK, N-A-C-K. If you encounter any error during processing, it's NACK. Okay. Again, very simple. Producer just generating every second some random number. Consumer listening to prices, getting it here. All right, that was all for Kafka demo. Hopefully, after watching this video, you have some more information about Kafka and its fundamentals. Thank you all for listening and see you all again next time. Bye.